Much like farmers and grocery shoppers count eggs in terms of dozen and bundle them up and make counting easier, chemists actually count in bundles too and make their life easy. It doesn't make a lot of sense to count particles in terms of dozen because 12 particles is far too few particles for us to be able to see and do anything with. But it does make sense to count in terms of Avogadro's number. In the world of chemistry, one increment is considered to be Avogadro's number worth. That's handy because we've learned that if we work with 6.022 times 10 to the 23rd of any of the particles, we can just snag the numbers off the periodic table and make them be grams. And that's what we call a mole. Now, while people seem to be perfectly content to use the word dozen with absolutely no idea where the word came from, for whatever reason, the word mole seems to upset people a little bit. A little bit of linguistics for you. The word molecule comes from the Latin mole, which means lump, and culus, which means tiny. So molecule means tiny lump. When chemists wanted to make a bigger group of this, they just dropped the tiny piece and it became a lump of matter. And that's where the word mole came from. The reason I wouldn't let you use MOLE as the abbreviation for molecule is because MOLE is its very own thing. So, taking a couple of our things from the other day, our 6.022 times 10 to the 23rd atoms of sodium that we determined weighed 22.990 grams, we call that a mole of sodium. And when we did the gulp of water, the 6.022 times 10 to the 23rd molecules of water, which weighed 18.015 grams, we call that a mole of water. So take a moment and calculate the mass of a mole of a couple of other things. So a little bit of math and calculator later, we come up with a mole of C12H22O11 weighs 342.297 grams, a mole of aluminum is 26.982 grams, and a mole of sodium chloride is 58.443 grams. These numbers, the 22.990, the 18, the 342, 26.982, and the 58.443, these numbers are called molar masses. So if you see a question that says, calculate the molar mass of whatever, all you have to do is add up the numbers from the periodic table, slap units of grams on it, and you're set. These little three-way equivalence statements are what we're going to refer to as mole sentences. And the skeleton for a mole sentence is actually on your resource sheet. If you look on the back side of your resource sheet, in the counting particles box, the mole sentence is basically there with blanks that you're going to fill in. So it's going to be 6.022 times 10 to the 23rd, and you're going to choose between atoms, molecules, or particles, so you're going to pick one of those three words, is equal to 1 mole, insert the chemical formula there, is equal to, add up the parts and pieces from the periodic table, worth of grams. When you're making the decision which of the three words to use between atoms, molecules, and particles, here's how you're going to decide. If it's an element, you're going to use the word atom. If it's a diatomic element or a molecular compound, that becomes molecules. And if it's an ionic compound, we're just going to keep on calling it particles. A time will come when you'll be able to write your mole sentence without any help, but until that time arrives, you're just going to use this as the skeleton and fill in whatever goes in the little blanks there in the underlined spots. Since we're working with lumps of matter, I decided that maybe the thing we should use was a lump of sugar. Now, you might be familiar with the phrase, would you like a cup of coffee? Would you like sugar, 1 lump or 2? The lump that they're talking about when they say 1 lump or 2 is actually a sugar cube. So if we take the mass of this little sugar cube, the sugar cube weighs 3.65 grams. Does my sugar cube contain a mole of sugar? No, because a mole of sugar would weigh 342 grams. That would be more like a brick of sugar rather than a cube of sugar. So we need to calculate what portion of a mole we actually have here in our sugar cube. How many moles in 3.65 grams? We're going to swipe our mole sentence from up above that goes with sugar. And that is that 6.022 times 10 to the 23rd, non-metal, non-metal, non-metal. So with those being all non-metals, it's going to be molecules, is equal to 1 mole, insert chemical formula here, C12H22O11. And we already calculated the molar mass to be 342.297 grams. I need to get from grams to moles. And now I'm going to get rid of one piece of my conversion factor. I can't use all three of these things at once. If I need to go grams to moles, the unnecessary piece is the 6.022 times 10 to the 23rd molecules. Now you're probably thinking, why would she make me write the whole entire thing if I'm not going to use the whole entire thing? Because 28 years of teaching chemistry tells me that if I don't make people write the whole entire thing, people start slinging numbers around randomly and things go bad very quickly. So this is a case where my 28 years of teaching chemistry experience is going to trump your 17 years of walking on planet Earth experience. And I am simply going to ask you to write the entirety of the sentence because I know that it will prevent bad mistakes from happening. Then we just have to solve our problem here. 3.65 grams. I'm going to use the 2 pieces I have left. 342.297 grams is 1 mole of C12H22O11. My grams cancel. I think about my significant figures. Three sig figs, 6 sig figs. I get to keep 3 on my answer. 3.65 divided by 342.297. And I round that to 3 significant figures. (107) moles of C12H22O11. So the answer to, would you like sugar in your coffee, 1 lump or 2, is actually, I would like 0.0107 lumps. Or if you like it a little sweeter, I would like 0.0214 lumps of sugar, please. 1 lump of sugar would be way, way too much.